Creating a frequency distribution, part 2. In this example, we are going to build a set of classes to hold all of the data. Here we have a new set of data showing commuting distances. What we're going to cover is how to determine those classes and then how to generate those frequencies. There's a couple rules that we need to keep in mind when working with frequency distributions. The first is that each of the classes should be the same width. The classes should not overlap. If you end with an interval at 9, you do not start the next interval with 9, because which of the classes would you put the value of 9? Third, each piece of the data should belong to only one class. So if you follow Rule 2, Rule 3 really isn't necessary. One other additional consideration is that it's often suggested that a frequency distribution should be constructed with 5 to 12 classes or intervals. If there's too few of intervals, the data may become too bunched and you cannot tell trends. And here's an example where the interval is, there's only 2 intervals here, and the only thing we can really tell is that most of them are under 0 to 36 miles. The other consideration with more than 12 classes is that we may gain more detail, but we risk losing clarity. And here's an example where there are so many classes that, again, it's making more of a challenge to determine any kind of trend by looking at a graph of the data. So keep these points in mind as we go through the next particular steps. So here we have a set of data for commuting distances from a set of students. First of all, we need to identify the smallest number, and if you scour the data, it's 0.2 of a mile. We need to determine the largest value. So again, looking through the data, it appears 53 is our largest. Next, we want to subtract the smallest from the largest value in our data set. We're then going to take that number and divide it by the number of classes. So using that rule of thumb, 5 to 12 classes, you select a number of classes. We've arbitrarily decided on 6 classes here, and we will determine the class width by dividing our difference between the largest and smallest number by the number of classes. Once you get this value, we will round it up to the nearest whole number, or the next largest whole number, which in this case is 9. Once we've determined the class width of 9, we can then establish our classes. So for the first class, it will be 0 to 9 for the commuter distance. Because we've ended with 9, we would begin with 10 in our next interval, and if you take your highest value and add your class width, it will give you your highest value for your next one. In the next class interval, 18 plus our class width of 9 means we'll go to 27, and we left off with 18, so our next value will start with 19. So 19 to 27. 27 plus our next class width will give us our highest limit for the next class interval, which is going to take us to 36, and 1 more than we left off for the lower limit. And continuing on, for each one of these, we have our 6 classes. Now we can go through the data and determine how many values for each one of these classes. So identifying the number of data values that are in this range, 0 to 9, we have red hash marks. There are 5 of them. So for tally marks, keeping track of it, we're using the traditional tally mark. 10 to 18 if we continue on in this fashion. These are the classes that have numbers from the data table, and frequency is just a matter of translating our hash marks into the integer that the hash mark represents. We had 5 in the first class, 6 in the next, and so on for the remaining ones. And now, seeing the frequencies, we can determine what the most common commuting distance is, the 10 to 18 miles for one way. We can see where the least is, the greatest, and so on. We can make lots of observations by having this raw data expressed in a frequency table. We've now come to the end of frequency tables, so that you can practice these concepts by completing the rest of the practice worksheet, Understanding Frequency Tables, problems 4 and 5.